Hello everyone, I hope I'm audible. So in today's class, I'll be dealing with logistic regression using user database. Last class, I showed you how linear regression can be used, giving an real-time example where we have to, know the sales product based on the advertisement. In this class, I have taken two examples. One is a user database, which is provided by a user community, which can again found it on any Kaggle or like anywhere you can find this user data. And second is the standard data set that is called MNIST. That is a data set that consists of different digits, and we need to identify those digits. We need to predict those digits. So moving with that, the first example is a user database. So as I told you, like we have deal with several libraries, and among them I have almost every time whichever sections I have taken or classes I have taken, I have mentioned these four libraries, that is NumPy, Matplotlib, Pandas, and Seaborn. It's not necessary like how I have kept all the libraries in one cell. You have to do that depending on your requirement. You can call your libraries at any time, but yes, you have to call the libraries before you perform any cell function. So again, I would like to repeat, my NumPy is used when I need to put my data in form of matrices. Okay, Matplotlib is used when I need to plot the data or visualize the data in the form of any kind of plot. Pandas are used when I need a certain data in the form of a data frame. So certain data like .csv. CSV is a comma separated variable, which means how we can see a data in the, it just think about a sheet which is having a lots of number, and those numbers are separated by commas. That's it, like 2 comma 3 comma 4 comma 5 comma 6, something like this. And you need to represent the data in the form of something which is shown like user id, gender, age, something like this. So that is where pandas are used. And Seaborn again is one kind of uh, plotting library which is used to plot maps such as heat map, confusion matrices, etc. So I have taken the data that is user data.csv. Again, you can find this data on Kaggle. You just need to type user data on Google, user data example for Python. You will get this data set. So calling my libraries first, I've imported my libraries. Now I'm reading this CSV file. So PD is for pandas dot read CSV, and the data I have stored in my drive. I'm taking the path of that drive to call that data. Now I need to see how my data looks. So I'm taking top 10 from the starting 0 to top 10 data empties I wanted to see. So what I can see is this data set is having a user ID. There's some user ID for information that is collected, gender, age, estimated salary of those age group, and purchase something which is our output. So this data set is like we have a gender and age group and their estimated salary, and we need to predict what is the rate of their purchasing. So belonging to that group, will they purchase, will they do the purchasing or not? So this is the data set given. We have to train our model onto that data set, and then we will deal with a new example. For example, if I'll give you a random salary and a random age, and I'll ask you, tell me if in this age group and in with this salary, will the purchasing be done or not? So this is what we do the as prediction. Moving ahead, so I need to know if my like this data set have any null values. It can be like the data set somehow there can be a human error in the data set, and some values can be a zero or which is not needed. So we need to see if that there is some null values. If there is some null value, we need to remove that. So this is what I have done, this df dot is null dot sum. After that, I need to predict whether a user will purchase the product or not. Okay, so what are the factors we need to see? So if you look at this data set, like just just need the age and estimated salary to know if the purchasing is done or not, because there is no role of gender, there is no role of user id. The purchasing or this output is not dependent on gender or user id. It is dependent on age and estimated salary. Okay, so to do the prediction and do the training model, we have to consider just this row, age, estimated salary, and output as purchase. So my input will be age and estimated salary. So what will be the number if I consider user ID as 0? So 0, 1, 2. So age will be at column 2. Estimated salary is at column 3. Purchasing, that is my output, will be column 4. So we need to take just those data. So see over here, what I have taken input as df.iloc. This iloc is like taking those datas, colon comma 2 comma 3. This means take all the values that is in the column 2 and 3. That's it. Similarly, for output, I am taking colon comma 4. Colon means how many values you want to take. I want to take all the rows of 4 columns. Similarly, I want to take all the rows of 2 and 3 column. So this is what I'm giving as input and output. I hope I'm clear with this thing. So now I need to split the data set. So till now what I have done is I have taken a CSV user database. I've converted into data frame using my pandas library. I have seen my data, what kind of data it is. I made a relevance if I need to predict, which is my output, that is how many purchasing has been done, is needed to be done. I need to find my input and output. So I have given my input as age and estimated salary, that is my column 2 and 3 of all the values, and my output as purchasing values. Okay. Now I need to train my data. So I'm splitting my data set into some ratio. So that ratio is not fixed. You can take according to your requirement, or you can even, you can do a hit and trial method. You can either take 70-30, 80-20, 60-40, anything. And you can just check in which splitting of data your accuracy is giving higher. Usually I consider 75-25 or 70-30, either of the two. So it is not necessarily that you have to take this much of training data set and testing data set. Obviously you cannot take 50-50, because that is more of like a 50. See, there is a logic behind keeping training set higher, because we need to our model to learn as much as it can, and then only we need to predict it. So prediction is on a smaller set, so that we need to know our model is working fine or not. So the priority is to train our model. So we usually try to give more of training data for prediction. So I have taken 25-25 ratio. So if you'll see, I have imported train test split from sklearn, and these are the common step which I am doing from last two classes. So X train, X test, this will be my input, Y train and Y test, my output. And I'm doing the train test split with, I'm keeping test side as 0.25, which means 25% of data as test side and others are as training data. And random state 0 is equals to, it is like I'm not defining among which data, like among hundreds of data, for example, which 25 data should be test site. It is taking randomly. So with that, I have splitted my data into test trend. Now my next motive is to, if I'll go back to my data set, no one asked this question, but you should have to ask, like, how you're going to make a prediction based on age and estimated salary and purchase, right? because my purchase value will be 0 or 1. Either it will be purchased, that is 1, or either it will not be purchased, that is 0. Right? It's a classification problem. It is purchasing is been done or purchasing is not done. That's it. My age and estimated salary is in different, you can say, scale value. Age will be not 19,000, right? Estimated salaries are in thousands or lakhs, but my age is something like in hundreds, max in hundreds. Okay, so I'm going to do the estimation with this thing. So for that I need to bring this data at a common scale. So this is the step where I have done a common scaling. What I have done is I have done a standard scaler. There's a function called standard scaler in sklearn. What it does is it will fit my, or like this fit underscore transform. So it will fit my data in a particular range in which I can do the prediction. And it's not just the training data that I needed to do. I have to do the testing data as well. So what I did was I fit my train data and my test data accordingly, like in the standard scale. So what standard scale does is it will fit your data from -1 to +1. So this standard scaler has certain formula inside it. When you will read, when you will go to sklearn documentation and search just about search standard scaler, you can see how this transform and standard scaler estimation is done. Okay. So with this, I have done my transformation. I now I need to see how my data will look. Okay, after transformation or after fitting the data, how my transformation will look. So this step is just to bring my all the data at a common scale. So if you can see, all the data are from 0.5 minus, like they are at one common scale. Okay, so my age and estimated salary feature values are scaled from -1 to 1. For your convenience, when you go through this, yeah, I forgot to share this thing. I'm so sorry. I just, so this is the collab notebook. I forgot to share. I'm so sorry. No one have even reminded me. Okay. So for your convenience, before every code, I have tried to write which you can understand, like in the form of text. So if you'll see, if you'll get stuck anywhere in the code, I have tried to explain with a statement which you can read and you can understand what what I'm trying to imply over here. So okay, so what till now we have done? We have imported our
Excuse me,
data.
ma'am.
Yeah, sure. Tell me.
Ma'am, it's asking for access.
Oh, I'm so sorry. I think I have not. I'm so sorry. Give me a minute just. I think, just a minute. Yeah, I think I've given the access. I'm so sorry for this. And yeah, like let me know if you are able to access it or not.
Yes, ma'am.
Yeah, okay. I would again would like to emphasize on making a copy of this. Just go to file, make a copy, save a copy in Drive, and then do this, because you cannot make any kind of changes or you cannot run this codes in my module, because I have not given you editor access. I have given you a viewer access. So what you can do is you can make a copy of it, save it in your drive, and then do whatever you want to. Like you just try this session is a hands-on session, so it's more of like you have to try on yourself. Just make any kind of error, that's not an issue, and ask me that error if you're going through it. So simultaneously you should go with the all the programmings which I am doing. If you want, I can wait for 5 minutes from the starting if you want to perform all the code cells which I have given. So let me know if you guys want me to wait for 5 minutes.
Excuse me, ma'am. Ma'am, I
Yep.
just wanted to ask, have we done worked on the data sets which have missing values?
Uh, no, I have not taken that data set, but this is what I have shown over here. If missing values or zero, so df dot is null dot sum. So this is where I wanted to see if my values have any missing value or any zeros are there. Okay,
Okay.
so this is null terminology is for that. If some values is missing or nan or like it's not applicable there, so it should be giving over here. And if we are having some values like this, we need to remove it. Okay, so that's a good point. I'll try to cover this kind of data in next class, whichever algorithm or model I'm going to give a hands-on training. I'll try to include this
Okay.
thing in that. Okay,
Okay.
but yeah, this is how you have to check if some data have a null value or nan value or any other zero value which should not be there. Okay, so I'll just wait for 2 minutes for you guys.
Kaushiki,
Yeah,
I had a small question, a couple of questions actually.
yeah, yeah,
The
please.
first is the first is related to the division of the data sets into train and test set. You
Yeah,
said that you want to maximize the data in the train set so that you can have a pretty good learning algorithm ingest as far data as possible. Okay.
exactly,
But my question is for the test set, you also need a sufficient amount of data to be sure that you are I mean, that you are confident in the metrics that the algorithm
exactly.
is giving. So how do you keep these are two conflicting these objectives, right? How do you manage between those? Are there any rules of thumb?
Exactly, yeah. So that is where I have, if you will notice, I have never ever mentioned that we should keep our training data 90% and our test data 10%, or
Yes.
95% training data or 5% test data. So
Okay.
this is where the constraint is. So there's no thumb rule as such, but
Mm-hmm.
what we usually prefer is we used to keep our training data into either 60-40 ratio, 70-30 ratio, 75-20, max to max we can go 80-20. So this is
Okay.
what thumb rule is. So mostly
Okay.
that where I emphasize that I usually prefer keeping my training and testing data in the ratio either 70-30 or either 75-25.
Okay.
So
That means you do not want to go below 20% for the test data. Is it right?
exactly, because
In normal circumstances.
because as important as is your training data, your test data
Mm-hmm.
is that important as well. So obviously if you are
Yes.
going
Yes.
to train your model with more of training data, it might be chances that there's something called overfitting of data. So your if you will
Yes.
keep
Yes.
your
Yes. Yes.
testing data as just 5% or 10%, your model can be
Mm.
overfit. What overfit means is, like, if it needed to predict something, it will try to over predict it. So the
Yeah.
result
Means it will pick up the noise in the training set.
exactly the outliers or the noises that can be
Yes. Yes.
come
They
into
will
the
pick up the
picture.
noises.
Exactly, so that will hamper your accuracy in terms. Okay, so this
Mm-hmm. I
and
got it. I got it. Yeah.
yeah, and we cannot keep it 50-50, 40, like 40% training or 60. That is again a terminology called underfitting. So this is how we have to
Mm-hmm.
do a trade off, or we have to keep a balance of 70 30 or 75-25. Okay,
Okay. Okay.
Excuse me,
Got it.
ma'am.
Got it.
yeah,
Got it.
please,
And while
please.
using the standard scaler, can we restrict it to convert it between 0 to 1 rather than -1 to 1?
Yeah, we can do that, we can definitely do that. So what over here I am not getting into that thing because that is not my priority. Okay, but
Okay.
there could be some data set where you need to keep it between 0 to 1 or some other scale. So for
Okay.
that you can give the values in standard scalar accordingly. But right now what I am doing is I'm just by default, when you use the standard scalar, it will transform your data from -1 to 1. So I'm just using the
Okay.
default thing. So obviously you can
Okay.
do that. Okay. So here we are. We are done with our scaling of data. Now we have to call our logistic regression. If you'll remember last time when I was doing the linear regression, I called sklearn.linear model. From linear model, I called the linear regression. Over here, I need to perform logistic regression. I'm calling my logistic regression. Can anyone just tell me one very important difference between linear regression and logistic regression?
Linear regression just plots a straight line differentiating between two classes, and logistic regression generally forms a curve. So we
Uh,
are able to classify the
Logistic
points more
regression
properly.
logistic regression gives output in a categorical data.
exactly. That's what I want to hear. What does categorical means? Either that will be a 0 or 1 or some values 2 or 3, but my linear regression was giving my values in continuous form. Okay, so that is some value like 0.2, 0.4, something like this. Okay, so basically my linear regression is used where regression things are being used, regression methodology are being used, and my logistic regression are used where we want to perform my classification, and classification is always either yes or no. Will it rain or no, it will it not rain, it is a dog or it is not a dog, it is a cat or it is not a cat, that's it. So over here my data set is exactly like this. My data set is like purchasing has been done or not done. So purchasing has been done is 1, purchasing has been not done will be 0, that's it. So I have, that is whereby I have used over here classifier. I can use anything. That this is just a variable, but I wanted let you know why logistic regression is being used over in this data set, and we cannot use linear regression model in this data set. Okay. So I have fitted my data. I have called my logistic regression, and my logistic regression model has been called. Now I need to predict my classifier. Okay, my classifier that has been predicted with X train and Y train. I need to perform my prediction on X test. So doing that, I did my Y prediction. Now there's something called confusion metrics. Do anyone know about confusion metrics? Anyone know about
Yes,
confusion?
ma'am.
Yeah, please tell me.
Like there are basically four sections. So the first section is like if it is predicted
Hmm.
correctly and the actual value is also correct only.
Okay.
And the second one is like if it is predicted like correctly, but
Hmm.
the actual value is not correct.
Okay.
And the one below the first one is like the predicted is false, but the actual value is true.
Okay.
And the last one is like both are negative, like both of
Okay.
them are false.
We
So
can say it as true positives, true negatives, false positives, and false
perfect.
negatives.
So why these true positive, true negative? Basically, my confusion matrix is evaluation metrics. What does evaluation means? Whatever the fitting, logistic regression model, training of my model, prediction of my data has been done, how to know and what to know like from my data. So what confusion metrics gives us is the performance of that model. What does performance means? If you remember in the when I was teaching you probability in probability class, I have mentioned about true positive, true negative. So what our aim from a model is, whatever, like how my model is basically is, my model is not nothing more than input and output, that's it, right? So what we usually do is we'll put everything in a model, and we need to see what, because we know what will be the output. For example, if I need to classify among a number of animals, which is a dog. Okay, so I'm giving the I'm training my model that okay, if these features are there, this will be a dog, this will be a dog, this will be a dog. So now randomly I'll give a dog picture and I'll ask it is a dog or not. So either it will say yes or either it will say no. Okay, so the output when it will be saying yes and it actually is a dog is a true positive, right? So my aim for any model is that true positive should be always higher in number. Okay, that my model performs well and predicts well. What if that is a cat picture and my model is predicting it as a dog, right? And I have trained my model for dog only, so that is like false positive. It is not a cat dog, but it is predicting as dog, right? So this is something called true positive, true negative, false positive, false negative. Okay, so this is how we see the performance of our model, that is called evaluation. Okay, between a predictive value, predictive result and actual result. Okay, so in sklearn, I would recommend you guys to go through sklearn documentation like really well, because there are so many libraries which can be directly imported from sklearn, and you don't have to put so much of effort in calculating those things. So even confusion matrix is one such library or one such function you can directly call. So sklearn matrix, I have imported my confusion matrix, and I need to do the prediction from y test and y prediction. Y prediction I've already done with my x test. Okay, so I have printed my confusion matrix, and what I can see is that the two students now just have told what confusion matrix consists of. So that is more of true positive, true negative, false positive, and false negative. So we can see my true positive and true negative 65 plus 24. It is giving the maximum value, and you can see my true positive is giving maximum value, that is 65. This means actually my like model is working pretty well, while false positive and false negative is pretty much less. Even my true negative is that important, how much true positive is important. Like if I'm training my model for a dog and I'm testing it over a cat picture, so it should say that it is not a cat, it is not a dog, right? So that is true negative. So even that value is good enough. So we can say out of 100, my true positive plus true negative is almost 89, right? While my false positive and false negative is uh, like around 11. Okay, so which is less, so my accuracy will be comparatively good. So I have used SNS to show that, just not the matrices, I just wanted to show you how we can represent also like my confusion matrix. So this is my true positive, this is my false positive, false negative, true negative. Okay,
Kaushiki,
yeah,
I just wanted to ask that in the logistic regression classifier, when you call that routine, you
sorry,
mentioned
I
the
can, yeah, please,
yeah,
please,
yeah. Can you hear me?
yeah, yeah, please, please, please.
Yeah. So when you call the logistic regression function in sklearn,
Uh-huh,
you mentioned the parameter as random state is equal to 0. Okay,
yeah.
but why did you mention? Because are you dependent on a specific solver? Because if you are using some specific solver, then only that argument is required by default.
Sorry,
I
which solver you are talking about?
No, see, I just going through the logistic regression, that thing, the library.
Uh-huh.
So there is a parameter random state, right? So you
Okay,
have
yeah,
default is none, but you
yeah,
have given 0. So
yeah,
it's written used when solver is equal to saga, or linear. These are
yeah,
three solvers, right?
yeah.
So I'm asking that are you using any specific solver? Means what is the intention behind including that in the logistic regression classifier itself? That's what
So,
I'm asking.
okay, so random state is just like I don't want to specify what kind of, how, like random state basically means if you like among hundreds of data, I'm telling take 75% of this data as training, so it can take any data. That's it.
No, that I understand you want for the training test split because you do not want
Yeah,
that randomness.
yeah.
Randomness that I understand. But
Okay,
in
so
the
you mean
logistic
over
regression
here?
fitting, yeah,
Okay,
yeah, yeah, yeah.
random
Why do
state.
you say yes?
Okay,
Why do you
so
mention that?
it is again the same thing. Like for the classifier, I'm telling you have to use logistic regression. So again, he have to take X train and Y train, right? So over here again, I'm saying you don't need to like. I'm not specifying anything. It can take any amount of like from that data. It have to perform logistic regression, so it can perform on any of the random state, like any of the data. It's not confined to a particular set of data. That's it. So it's not none of that concern. Random state is equals to 0 is not that of concern.
Means if you omit it, also nothing will happen, right? If you
Yeah,
omit it from the.
exactly, exactly.
Mhm. Okay, okay, fine.
Okay, so confusion matrix is done. Now my next part is to know how much accuracy I'm getting. Although we have already calculated that is 60, like my accuracy is nothing but this. If we are talking about a small data set and if we are having just this confusion matrix, my accuracy is nothing but diagonal matrices, sum of diagonal matrices. Okay, so 65 plus 24, 89. So we know my accuracy will be 89%, but just to calculate my accuracy, 89%, we are able to calculate it in this case when we have just a small confusion matrix value. When we I'll I'll show you a very large data set that is having a thousands of datas in it, and more than two classes to predict. So in that my confusion matrix will also be more, like the values will also be more. So in that case just by adding this two values will not be enough. So we need to find the accuracy. I'll just show you. So my accuracy is 89%, which is comparatively good enough. I need to now visualize my performance of my model. This is just something extra which I have included. If this is enough. Like my model is trained, my prediction is done, my accuracy is 89%. Well and good. Now I just need to visualize the performance of my model. I've done nothing. It's just if you'll go through it, these are just like plotting and matplotlib functions are there, and how you can plot a data. That's it. So don't put your head into this much. I just want to visualize you how my testing and this is done. So estimated salary and age I have taken, right? So this red color tells me 0, it means purchasing has not been done, and green color tells me 1, this means purchasing has been done. So this straight line is the one which is separating and giving my maximum values, where my separation can be done. Basically, logistic regression or linear regression, we have a cluster of data, and we need a certain line among that data which can separate the two data perfectly. So I just want to I just want you guys to visualize how this has been done. So this is how my prediction has been done. Okay. Now, this was a very small data set, a user based data set that was easy enough to process. Now, I'm taking a very standard data set. You will hear this data set a lot of time if you're going to work in image processing domain. So, the data set is called MNIST. It's a handwriting data set where thousands of handwritten digits has been taken, and a data set has been created. So what my problem statement of this solving will be, we have a from 0 to 9 we have a data set. We are going to train our model on that data set, and now we are going to predict a different kinds of handwritten digits, and we can see if the my model trained model can predict that handwritten accurately or not. Okay. Again, my MNIST dataset is a standard dataset that has already been created by this institute, Modified National Institute of Standards and Technology. This database consists of a handwritten digits, thousands of handwritten digits. So I will be training my model, like my logistic regression model, on this dataset, and then I'll be testing on a different digits dataset to predict if that my model after training can predict accurately or not. So first thing will be to fetch the data set. So this data set you can find on sklearn.dataset. I can fetch OpenML. There's something a function called fetch.openml, and in that my MNIST data set is present with the name MNIST 784. Why 784? Because its dimensionality is 784. That's it. So you can see there were, I'll just show you the shape and size, shape of both input and output. So my input, I have already pre-run it. I'll run it again, but I'll just explain you meanwhile. So my the shape of my input is 70,000 images. Think about it. So we are now going to work on 70,000 images. Okay, which have dimensionality 784. So what does dimensionality means? Number of bands. So I told you, like my data set is always in rows and columns. So you can say it has 70,000 rows and 784 columns. That's it. That is my input. And my output is, okay. Give me a minute. It's running pretty well. Just give me a minute. I'll just short it out. Let's. Okay. So. Okay. Okay, so let's do one thing. I'll just this is, I don't want to waste the time on this. I'll just let you know there's some error I have to figure out. I'll figure this out. I hope I'll not get the error in this. Let me run this. I hope I'll not get the error. Oh my god. Okay, give me a minute. So sorry guys, just give me a minute. Yeah. So I think it will work. Yeah, right. So moving ahead, my X is my input, which is 70,784, and my Y is output, that is labels. So that is 70,000 again. Okay. So now again, I would like to split my data set, right? So splitting my data set in this, what I'm doing is I'm splitting my data set by 1 by 7, 7.0. 7.0 means I'm taking this as 70,000. This means I'm splitting my data set into making the training set size of 60,000 and test size of 10,000. That's it. 1 by 70,000 it means. Okay. Now I want you guys to see how the data set looks like. So what I've done is I have, okay, so explaining into this, I have plot of figure 20 dot comma 4 means size of the width of this image should be 20, and 4 is like in one column there should be 4 images. If you can see 4, yeah, 4 means 0 1 2 3 4, that is 5 images. Okay. And for index, I have given train the image from 0 to 5, train the label from 0 to 5. These are just, if you'll read about it, you'll get to know it. It's nothing. I just want to show you how my data set can look. So these are the numbers among all the data set. These are the numbers which you can see. Just the example data set. So again, I need to import my logistic regression. I'm again calling my logistic regression from sklearn. And there is something called okay, yeah, so there was someone who was asking me any kind of solver you have used or not. Now I got your question. I was not able to understand that time. So yeah, when we deal with a larger data set, okay, so we cannot do just, we cannot ask the model to randomly take the data set. We need to define certain solving values so that my model can work fastly. Otherwise, if we'll not put this solver, my model, just think about 70,000 images, so my model just to train it will take a lot of computation time. Okay. If you can remember, just to call my model, this MNIST data set, it took almost 2 minutes. Okay. Which was not in the case of user database. So that is the reason where we use the solver. And in this, there's different kinds of solver. You can read about it. There's one such solver called LBFGS. So I'm just using it to make my processing or my training of data a little bit faster. That's it. It's of, like, that is the use of the solver. Okay. Now moving ahead, I need to fit again my this train image. If you'll go back, when we were using with training, like my data user database, we were using 4 terminologies: X train, X test, Y train, Y text. Similarly, over here, I'm taking train underscore image. So train, there's two things like training and testing, right? Similarly, X and Y was my X is input, Y was my output. Over here, Training and testing are same the terminologies. Instead of X and Y, what I'm using is image or label. So image is my input, that is X, and label is my output, that is Y. For your convenience, I have also written this over here. Model is learning the relationship between X and Y, that is digits and labels. Okay. So again, fitting my regression over here. See, so like it is very much you know needed that your model should learn or train faster. That is why we are working in machine learning. That is what is the use of machine learning and advanced version of machine learning, that is deep learning, neural network. These are the benefits of that. If we are going to take a lot of time or the memory or computation time, then there's no use of coming into this machine learning, right? So basic machine learning means automate your process with computer without using much of your energy. So you can see how, like, since the data set was so large, it took almost 2 minutes to even train the data set, both image and label, which was not in the case of user database. These are just the warnings. This is no, don't worry about it. Until unless it is tick, like until and it is a cross, don't worry about it, there's no error. And the best part about Python is it will always tell you where your error is coming, what is the error in your program. Now it has been done. Now I need to predict my test and training data set. So again, over here I have reshaped 1 to -1. The same thing, like I need to know, like I need to keep a balance, like a normal scale. But in like our user database, there were values. In this we have images, so we don't need to use the standard scaler, which we need to keep -1 to 1 the values. We are just reshaping our image values, that's it. So we are predicting on, we are taking test image 0 to 10, we are just predicting what are the values. So we can see, from if you are taking 0 to 10 element, these are the predictive values. Okay, we'll see, I'll show you in terms of. Okay, so my accuracy is around 0.91%. I'll do the, I think I have done the confusion metrics below. Okay, so what I'm doing is, now I'm predicting it. Ki, how, like if there any misclassified data is there or not. So, okay, this is what I wanted you to show. See, this is 0. What I've done is, I can see plot predicted is 0, actual is 0. Predicted 4, actual is 4. Predicted is 1, actual is 1. Predicted 2, actual 2. But this is over here is error. Predicted 4, but actual it is a 7. So this is a misclassification. So this is what I wanted to show you with the that 9% of accuracy where it is going. Okay, and yeah, here it is my I've done the confusion metrics. So I'll tell you about the confusion metrics as well, how the confusion metrics has been calculated, because it's we okay, I'll tell you in this will be more of visualization purpose. Okay, so if you can see, if we'll go to the database user database example, we just have we need to predict either 0 or 1, right? And we just have two classes. One was estimated salary and one was age. So my prediction was either 0 or 1. Over here, how many classes do I have to predict? We have 10 classes. How 10 classes? We from 0 to 9 digits. So if you'll count from 0, 1, 2, 3, 4, there are 10 classes that needed to be predicted. It means if the value is 4, that means, okay, what I meant is, in my user database, my output was either 0 or 1, which 0 means purchasing has not been done, 1 is purchasing has been done. So my matrices was 2 cross 2. That's it, right? But in this example, we have a output from 0 to 9. 0 to 9 as 0 means 0 digit, 1 means 1 digit, 2 means 2 digit. Similarly, 9 means 9 digit. So this is how we are representing over here are my data. It means it predicted 4, it actual is 4. And that is what digit is 4. It can be something else as well. I'm talking about the place value as well as the numerical value. So my output classifier has 10 values, and this is why my accuracy score, that is 91%, is giving my confusion matrix into 10 cross 10 matrices. Okay, why 10? Because it is from 0 to 9, and this is the prediction is done between actual level and predicted level. So now if you will add all these diagonal matrices and divide by how many images we were having, 70,000, right? So if you will divide by 70,000 images, you will get this code, that is 91%. So again, in this also this will work, but this is very tedious task, right? We cannot just add all the diagonal matrices and you will just calculate manually. You cannot do that. So this is how we do the uh, like logistic regression or confusion matrix. My values are calculated. So yes, this is what I wanted you guys to know. One was a smaller data set, that is a user database which has been provided, and one is a standard data set which is a huge data set. So I think I'm pretty much done for today. Let me know if you guys have any question. We can deal with question for next 10 minutes. I hope I'm audible.
Ma'am, can you discuss about the assignment which have given us?
Assignment, I'm not the right person to discuss about. I think from 4 o'clock, you are going to have a class with Raj, and he's going to take up with that session. So I think you can discuss it over there.
Okay, okay, ma'am.
Yeah. Anything related to today's class, or if you're working on yourself with Python or something, so please let me ask.
Ma'am,
Yeah.
I have
Madam,
question.
madam, do we have this user data? Because we are unable to run without that.
Yeah, that's what I told. Okay, I'll just show you. Just write user data Python, or just write logistic regression, right? You will get it. Search it. I think in Kaggle itself, there's something called Kaggle. This is a platform where you can get all, yeah, you can get all the data set. If I'm not sure, if you want, I can share this data set as well, but I think there should be some data. Okay, it's a weather. What I'll do is I'll just share this data set with you guys if I can over here in the chat box. Uh, okay, I have it in my drive. Yeah. So I'll just give the access to download it. I'll give the editor access so that you can download it. Okay. So this is where you can find your data. I'm just putting it in chat box.
Can you share the link also? Actually, I'm joining little late, so that this link is not available for me.
Sorry, what?
Can you share the link of this session we have taken?
Link of this session. YouTube you are asking about?
No, no, that is logistic regression. जो you have
Okay, the
program.
this. Okay,
Yeah,
okay.
yeah.
Yeah. I'll do that. Yeah, so here it is. And I have a you like I'm uploading all the lectures which I'm taking that has been recorded and can be you can rewatch it on my YouTube channel, because we have to upload it there. If you want, I can share you that as well. or
Yes,
yeah,
ma'am. Please,
give me a
please.
minute, I can show that as well. So this is the link for my channel. You can find all the videos of all the sessions over there. I hope this can help you guys.
Okay, ma'am. Thank you very
Yeah.
much.
Okay, then thank you for today's class.
Can you share the previous collab notes?
Sorry, what?
Can you share the previous class collab notes?
I think you can get those like there is a sheet where all the sessions are being put up, including YouTube links and collab uh, notebook as well. So I think you can get it from there. If not, um, then I can share you. I don't know if I can share it with you or not. Okay, just remind if you're not able to find in this week, just remind me. I'll share it with you next week because by this week I'll just confirm if we are fine enough to share this with you guys or not.
Okay, ma'am. Thank you, ma'am.
Okay, thank you.
Kaushik,
Yeah,
hi. Yeah, actually, this last that problem you solved, it can
yeah.
be solved with the neural network also, right?
Exactly. There's
Image.
so like that is a standard data set and that will be used so many times and you can solve it with so many algorithm. It's not like necessarily you have to use logistic regression. I just
Uh,
took it as an example. Yeah.
okay. And one more thing,
Mm-hmm.
but in Kegel's, I found many datas like related to my field, like material science.
Mm-hmm.
There are lot of datas are missing or that, but we feel that it is important. That time, what we will do because like majority is missing. That what time we can't means
So
neglect the
there's
data.
yeah, I got your point. There's something called data pre-processing. So in
Okay.
pre-processing, what we do is we remove all the data set, we modify the data set according to our need. Like
Okay.
user database, I told you there were 4 columns. There can be hundreds of columns, but I would be needing just those 2 columns and that one output column. So I just extracted that column, right? I don't care what all columns or what all values inside it have. So similarly, dealing with these kind of data set, you need to do a pre-processing of your data set where you need to extract what columns you want to work on. You need to remove all the nan and zero values, and there's so many other steps are there. So
Yeah.
if
Yeah.
I'll get a chance, I'll try to take a class on pre-processing of data, and maybe that can help you.
Yeah. Sure. Thank
Okay,
you.
thank you for today's class.